This video will be on transformations of and modeling of sine and cosine functions. But first, let's start out with transformations of these functions. So when we're dealing with transformations, we like to deal with them in standard form, which is the two equations below of y equals a times sine of b times x minus c, then all plus d, and y equals a times cosine of b of x minus c plus d. Through this video, you'll see how all four variables of a, b, c, and d affect the parent graphs of y equals sine of x and y equals cosine of x. Let's start out with the amplitude. So in trig, the a in the functions y equals a sine of x and or y equals a cosine of x refers to the amplitude. This is equivalent to a vertical stretch or shrink of the parent graph y equals sine of x or y equals cosine of x. So here we have y equals sine of x, y equals 2 sine of x, and y equals 0.5 sine of x, with the y equals sine of x having an amplitude of 1, meaning that the max is 1 and the minimum is negative 1. Then for y equals 2 sine of x, we have an amplitude of 2, so the max and minimum are multiplied by 2, so we have a max of 2 and a min of negative 2. And finally, for y equals 0.5 sine of x or y equals 1/2 sine of x, we have an amplitude of 1/2, so the max and min are both multiplied by a factor of 1/2, so the max is 1/2 and the min is negative 1/2. Now for frequency, in trigonometry, the b in the functions y equals sine of b of x or y equals cosine of b of x refers to the frequency which is affected by the period. This is equivalent to a horizontal stretch or shrink of the parent graph y equals sine of x or y equals cosine of x. So here we have y equals cosine of x, y equals cosine 2 of x, and y equals cosine of 1/2 of x. So the frequency over 2 pi radians would be b over 2 pi. So the b here is 1, so it's 1 over 2 pi, and b is equal to 1. Here, y equals cosine 2 of x, the b is equal to 2, so we have 2 over 2 pi, which is just equal to 1 over pi. And finally, we have the b being equal to 1/2. So we get 1/2 or 0.5 over 2 pi, which is equal to 1 over 4 pi. Then this gets us what the period is. Since period equals 2 pi over b, we know that from y equals cosine of x, what's on bottom is 2 pi, so the period is 2 pi. With y equals cosine 2 of x, a pi is on bottom, so therefore the period is just pi. And for y equals cosine of 1/2 of x, what's on bottom is a 4 pi, so therefore the period would be 4 pi. Now let's bring together what we just learned about amplitude and frequency and period to determine the amplitude and period for each of the following equations. First, with y equals 1/5 sine of 3x, we know that a, or the amplitude, is equal to 1/5, and b is equal to 3. Therefore, the amplitude is 1/5, the frequency is 3. So if we wanted to find the period is 2 pi over b, or 2 pi over the frequency, so the period is 2 pi over 3. Next, for y equals 3 sine of 1/5 of x, we know that the amplitude is 3, and the frequency, or b, is 1/5, so the period would be 2 pi over b, or 2 pi over 1/5, which would be 10 pi. Now let's move on to displacement. In trig, the c in the functions y equals sine of x minus c or y equals cosine of x minus c is referred to as the displacement or phase shift. This is equivalent to a horizontal shift or translation of the parent graph y equals sine of x or y equals cosine of x, with x minus c meaning the graph is moving c in the positive direction, and x plus c meaning that the graph is moving negative c or moving c in the negative direction. So here we have y equals sine of x, y equals sine of x plus pi over 4, and y equals sine of x minus pi over 4. So at the start of this cycle, for y equals sine of x, we know it's at 0. and then at the end of the cycle, it's at 2 pi. Then for y equals sine of x plus pi over 4, we know that the graph shifts negative pi over 4, so the start of the graph would be at negative pi over 4, and the ending of the graph would be at 7 pi over 4. Then for y equals sine of x minus pi over 4, we know the graph shifts pi over 4 in the right direction or the positive direction, so the graph would thus start at pi over 4, or the cycle would start at pi over 4, and the cycle would end at 9 pi over 4. Finally, we have the midline. In trig, the d in the functions y of sine of x plus d, or y of cosine of x plus d, refers to the midline. This is equivalent to a vertical shift or translation of the parent graph y equals sine of x or y equals cosine of x. So first, we have a regular y equals cosine of x, and then y equals cosine of x plus 2, and then y equals cosine of x minus 2. So with y equals cosine of x, we know that the max is at 1, and the min is at negative 1, so therefore the midline is at 0. For y equals cosine of x minus 2, the graph is shifted 2 units down, so the maximum becomes negative 1, the minimum becomes negative 3, and the midline becomes negative 2. And finally, for y equals cosine of x plus 2, we know the graph is shifted 2 units up, so the max becomes 3, and the minimum becomes negative 1, or becomes 1, sorry, meaning that the midline would be at 2. Now let's pull that all together, what we've been talking with amplitude, period, displacement, and midline, with a couple of example equations. First, we have y equals 1/3 sine of 4 of x minus 2. So we know that the amplitude, or a, is 1/3. We know that the period would be 2 pi over 4, or pi over 2. Since there's nothing that the x is being, or there's nothing being subtracted from the x, there's no displacement, so it's 0. And therefore we know that the midline, finally, is y equals negative 2, because d is equal to negative 2. For the next one, we have y equals sine of 1/3 of x plus 1. The amplitude is just 1, because there's a 1 in front of the sine. The period would be 2 pi over 1/3, or 6 pi. There's nothing being subtracted from the x, so displacement 0, and the midline would be y equals 1. For the next one, we have y equals 2 pi of x minus pi plus 2, so the amplitude's 2. It's a regular x, so the period's 2 pi. The displacement, it's negative. The x is being subtracted by pi, so the displacement is pi in the right or positive direction, and then the midline would be y equals 2. Finally, for 5 cosine, or there should be a y equals in front of that, so y equals 5 cosine of 0.5x plus pi. We know that the amplitude's 5, and then since b is 0.5, that means the period has to be 4 pi, or 2 pi over 0.5, which is 4 pi. And for the displacement, it can be kind of tricky because now we have to take the b out of the equation. So now it's just, so we take the 0.5 out, so it's 0.5 times x plus 2 pi, therefore meaning that the displacement is not negative pi, but negative 2 pi, which goes back to the equation, which is y equals a of sine of b of x minus c, or y equals a times cosine of b of x minus c. So the b has an effect on what the c or displacement is. And then finally for the midline, there's nothing being added to the cosine, so the midline is just y equals 0. Now let's get into graphing these transformations. First we have y equals sine of 1/2 of x minus pi over 4. So we want to take the 1/2 out, so we get y equals sine 1/2 of x minus pi over 2. From this we can figure out that a equals 1, b equals 1/2, so the period is equal to 4 pi. And then each interval, well, an interval is just the period over 4, so the interval for this graph is going to be pi. and then we know c is equal to pi over 2, and d, or the midline, is 0. So the graph would look like this. We would have it going up to 1, going down to -1, and then we would have pi over 2, and this one would be 3 pi over 2, this one would be 5 pi over 2, 7 pi over 2, and then 9 pi over 2. Since it's a sine, the sine graph starts at the midline, and then since it's a positive sine, it goes up to 1 at 3 pi over 2, then comes down to 0 at 5 pi over 2, down to -1 at 7 pi over 2, and back up to 0 at 9 pi over 2. So that's how that graph would look. Don't forget to draw arrows to show that it's continuous. And then let's go on to the next one. Now for this one, the graph, or the function, is y equals -9 cosine of 2/3 of x minus 4. So the amplitude here is going to be 9, and you might be thinking to yourself, what about the negative? The negative just means that the graph is going to be flipped on the y-axis. Here we have that, I'll show you what that means in a little bit. Here we have b is equal to 2/3, so therefore the period is 2 pi over 2/3, which is just 3 pi. That means we have intervals of 3 pi over 4. Nothing is being added inside the parentheses, so there is no c, and d is just -4. So now we can make a graph out of this. So since the midline is y equals -4, and the midline didn't matter that much in the previous one because it was 0, but here it's going to matter a lot, because instead of just the graph going up to 9 and going down to -9, it's going to go up to 4. It's going to go up to 9 plus -4, and down to -9 plus -4. So it's going to go up to 5 and down to -13. Since there is no c, there is no displacement, so the graph will start at 0, and then the intervals are 3 pi over 4, so 3 pi over 4, and then 3 pi over 2, then 9 pi over 4, and then 3 pi. Now, since the graph is negative cosine, that means the cosine is flipped, so instead of starting up here with 5, it's actually going to start down here with -13. So, and then it's going to go up to 3 pi over 4, then it's going to go up, or it's going to go up to -4, then it's going to go up to 5, then it's going to go down to -4, and then back down to -13. So like this, and then arrows to show that it is repeating. Something I think that's helpful to realize and to know is that sine graphs, whether they're positive or negative, are always going to start at what the midline equals to. If it's positive, it's going to start out going up. If it's negative, it's going to start out going down. Then for cosine, they start at where the midline plus or minus the amplitude is. If it's positive cosine, it's going to start at d plus a. If it's negative cosine, it's going to start at d minus a. And then positive cosines are always going to start out by going down, and then negative cosines are always going to start out by going up. Also, d plus a just equals the maximum value of the graph, and d minus a just equals the minimum value of the graph. Now that we know how the graph, sine, and cosine functions, let's try and write an equation for the sinusoidal functions given the information about its graph. In problem A, we see that it's a sine function of a period of pi, a midline of 10, an amplitude of 4, and a displacement of -pi over 4. So we know that the period is 2 pi over b. So if that is equal to a period of pi, that means b has to be equal to 2. If the midline is 10, that means d is equal to 10. If the amplitude is 4, that means a is equal to 4. and if displacement is negative pi, that means c equals negative pi over 4. And if we're going back to the equation, the standard form from earlier, we know that y equals a sine of b x minus c plus d. So that means that this equation would be y equals 4 sine of 2x, two negatives make a positive, plus pi over 4 plus d, which is 10. And then if you really wanted to, you could distribute the 2 to the x and to the pi over 4. Now for problem B, it says a cosine function with max of 6 at 2 pi and a min of 0 at pi. Therefore, we know that the midline, or d, is 3 because it's halfway between 6 and 0. And then we know that a is 3 because 3 plus 3 is 6 and 3 minus 3 is 0. Now for the period, we know that the graph has a maximum at 2 pi and a minimum at 0. Therefore, it would also have to have a max at 0 if it was going to be a cosine function. So if the max is at 0, that means there is no displacement. So c equals 0. And therefore, since it has, if it's going from 0 to pi to 2 pi in one cycle, that means that the period is equal to 2 pi. That means b is equal to 1. So cosine has the same standard form as sine. You just switch the sine to a cosine. So this equation would be y equals 3 cosine of 1 x minus 0 plus 3, which just equals 3 cosine of x plus 3. Now, another way of using what you know about sine and cosine is writing equations from the graph. So here it's asking to write a negative sine and negative cosine equations for the graph. So here the midline is not at 0, it is actually at negative 1. So that means that d equals negative 1. We know that it goes down to negative 4 and up to 2, so the amplitude equals 3. We know that the period of one of these cycles going up and then down and then back up again is from negative 6 pi to 2 pi, which would be 8 pi. Therefore, b would have to be 1/4 because 2 pi over 1/4 is 8 pi. And then for c, it depends on where you want to start the graph. If we're doing a negative sine and a negative cosine, we'd prefer to start it where the sine is going down and the cosine is at the negative max. So we would prefer to start it right here for sine and right here for cosine. So for sine, the displacement would be negative 2 pi, but for cosine it would be 0. So for sine, it's y equals 3 sine of 1/4 x. Two negatives make a positive, so plus 2 pi minus 1. And then for cosine, it's y equals 3 cosine of 1/4. There's no displacement, so it's just x minus 1. And then since both of them are negative sine and negative cosine equations, there has to be a negative sign before the 3 and y equals negative 3 sine, and then before the 3 and y equals negative 3 cosine. Now the final part of this video will be on modeling with sinusoidal functions. Really, with modeling, you just need to know what you're looking for. You need to look for your amplitude, your b or your frequency, therefore your period, and then your displacement and your midline, and you need to know what direction you're going in. Are you doing it a positive graph or a negative graph, or a positive cosine function or a negative cosine function, or a positive sine function or a negative sine function? And all this can be seen from the graph like we just did, or they'll give you a word problem to do and you have to find a function. But really it should be pretty simple. And that's really all you need to know for transformations of and modeling of sine and cosine functions.